Now that we've talked about orbital diagrams and we've kind of introduced the concept of sublevels and orbitals and electrons, we want to go into electron configuration. Now, electron configuration is simply a way of writing out the electrons in the order they go in, and it's kind of like finding an address on the periodic table for that element. It's kind of a unique identifier. Now, remember last video we talked about how each row on the periodic table represents an energy level. So we have 7 energy levels, okay? But each energy level has several sublevels in it. Column 1 through 2 represents the S sublevel. Column 3 through 12 represents the D sublevel. The rest of them is sublevel P. Helium goes over here with hydrogen, and then these down here are the F sublevel. Now, if we're going to write the electron configuration, for example, if I want to write the electron configuration for carbon, okay, what I would do is I know that carbon is number 6 on the periodic table, and I'm going to put a little mark in each box until I get to carbon, and I will put one in carbon as well. Okay, so to write my electron configuration, what I would do is I would read the periodic table like a book and stop when I get to carbon. So if I'm reading it like a book, I get to energy level 1, sublevel S, and there are 2 dots in my boxes. 1, 2. So I would write the exponent 2. So that takes care of those. Everything on the first row. And now I would start at my second row. That's energy level number 2. I'm in the S sublevel, and I have 2 dots in my boxes, so I would put the exponent 2. That takes care of those. If I keep going across, I land here. I'm still on my second row, so energy level number 2, but now I'm in the P block, and I have 2 dots that have been filled in. I stop at carbon because that's the element they asked me for. So my electron configuration would be 1s2, 2s2, and 2p2. Now, if we're breaking down what they mean, okay, the 1 represents the energy level of an electron configuration. The 2 also represents an energy level, but the S is our sublevel, and the exponent is the number of electrons in that sublevel. So this kind of shows us its electron configuration. Now, if you look at just the last part of this electron configuration, 2p2, you can use it as an address. So 2 tells me energy level 2, p tells me I'm in the p block, and the exponent 2 tells me 1, 2, talking about the second one. If I gave you an electron configuration that looked like, let's do this right here. Let's clean up some of that. If I gave you an electron configuration that looked like this, 1s2, 2s2, 2p6, 3s1, and I said, what element is this referring to? I would only have to look at this last part. The number 3 tells me I'm looking at row 3. The S tells me I'm looking somewhere in this S block, so it's one of these. And the number 1 tells me it's the first one. So that means 3s1 is talking about sodium. 3s2 would be talking about magnesium. So you can kind of go through the periodic table. 1s1, 1s2, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, and so forth. So if we do some practice with this electron configuration, let's look back at our notes. So our notes had some examples. If we look at lithium, Li, we can note that it would be 1s2, 2s1. Lithium is on my second row, sublevel S, and it's the first one, so we would stop there. Carbon, we did as our example earlier, would be 1s2, 2s2, 2p2. Sodium, in A, if we look at sodium, sodium is in row 3, sublevel S, and it's number 1. So sodium's electron configuration would look like 1s2, because we would put 2 dots. We would really put dots in every box up until sodium. So if we do that, okay, and we read through, 1s2 covers those. Now I'm on energy level 2, sublevel 2, there are 2 dots. So I put my exponent 2. I come across over here, and I'm still on row 2, sublevel P, and there are 1, 2, 3, 4, 5, 6 dots. So I put the exponent 6. And then I go to row 3, sublevel S, and I only have 1 dot, and I stop there, so I put the number 1. So that would be the electron configuration for sodium. Now, if I were to keep going, what if I wanted to know the electron configuration for potassium, which is K? Potassium would need to add several more electrons, several more dots, and I would keep going. It would be the exact same as sodium for the first part, but instead of 3s1, I now have filled in my second dot. So it would be 3s2, come across, 3p1, 2, 3, 4, 5, 6, 3p6, and then I come down here to 4s1. So we can continue to write our electron configuration that way. If you need more help, you might need to come in for tutoring for this. It can be a challenging concept to understand if you're not getting enough practice or you have questions. But if we want to look at noble gas configuration, okay? Noble gas configuration have some examples in your notes right here. It's also called our shortcut configuration. The reason why is noble gas configuration is kind of like how you put a bookmark in a book when you're reading it. Now, when you put a bookmark in there and you go back a couple days later to keep reading, you don't start all the way at the beginning of the book again. You start with where your bookmark is. So, if I wanted to look for the noble gas configuration of copper, okay, first I'm going to show you the electron configuration normally for copper. Copper would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and remember when we're in our D sublevel, which is right here, that center section, we have to subtract an energy level. So instead of being 4D, it would go to 3D, and I would count my number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Copper is the 9th one, so I put 3D 9. Now, noble gases are in our last column, column 18. These are our noble gases. Now, for noble gas configuration, what you do is you figure out the one that's closest to us by going up and all the way to the right. So that means the noble gas for closest to copper that still has less electrons would be argon. Argon has an electron configuration, and let's just go ahead and label this. This is copper. Argon has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6. And we stop there. Now, if you'll notice, argon and copper have something very, very similar about them. All of this is the exact same thing. So instead of writing 1s2, 2s2, 2p6, 3s2, 3p6, we can use our noble gas configuration as a shortcut. We can put the symbol for our noble gas, argon, in closed brackets, and we write what's left over. 4s2, 3d9. It's much shorter that way. Let's do another example. If we want to do the noble gas configuration of silicon, silicon is right here. So to pick our noble gas, we would go up one energy level and all the way to the right. So my noble gas is neon. So I will put neon in brackets, the symbol, and pick off where I left off. Okay, after neon, I would be on row 3, and I would have 3s2, and then come across 3p2. And that would be the noble gas configuration for silicon. So if you use this method to practice your practice problems, you will be good to go. But this does require a lot of practice in order to actually get good at it.